But it says Switzerland covers the Alps with solar panels now that they've achieved something impossible. But Jeff, did you see this article? Because it's almost like they're tricking you into it. It's a little clickbait with the fact that they're covering the Alps with solar panels, but they didn't really cover the Alps.
They're not covering the Alps. Welcome to I Like Batteries, the show where we explore the world of batteries. I'm Jeff Lynch.
And I'm Mike Muldoon. Good morning, Jeff Lynch.
Good morning, Mike. It's a lovely morning here in Harpswell, Maine. How about down in New Hampshire?
Hampton, New Hampshire looks great, too. We've got some good, it looks like a good solar day. Although I will say, we didn't say this in pre-show, I went into the battery shed just to get some things because shed's doing great, but doing a lot of work out there, really getting that to where I need it to be. But I looked at my EcoFlow Delta Max, and it was at 18%. I'm like, what's going on? And I know I was charging some things off of it, but it was a pretty sunny day yesterday. Well, you get this at nighttime. I think it's trying to pull a little power from the solar panels as it gets to later in the day. So it has this little clicking sound, and I was trying to concentrate on something, so I unplugged the panel. And so got to remember, if you unplug the panel, you need to plug the panel back in. So that was my dilemma. That was a problem. ID10T error on my part, for sure. Mm-hmm. Yeah, ID10T error.
That happens.
Well,
we had a similar thing happen here with Alice's computer. We are doing some construction in our house, and we had moved her standing desk out of the way to remove a radiator.
Sure.
Because we went with heat pumps, so all the radiators had to come out. So I was like, oh, we had the dumpster, so I got the Sawzall, and I chopped it out. And she put her desk back together, and she plugged her laptop in, and she's like, wait, the monitor's not working. And I even went and I looked at it, and I'm like, oh, that's strange. So I'm like, I grabbed the cable, the monitor cable out of the back of the little hub, and I put it in the side of her laptop. And the machine thought it was there, but the display didn't light up. And I'm like, I can't deal with this right now. It turns out the power strip wasn't plugged into the wall. So
yes.
Like, is it plugged in? You know, the first question we should all be asking ourselves.
Always. Is it plugged in? It's always a good one. And hopefully, you know, being that it's dawn, there's some things that are plugged in, because there was something fairly significant this dawn this morning. And this, obviously, our show comes out a little bit after the day that we record. So there was something that was pretty important or somewhat historic. And that is that if we look at the Polaris Dawn had launched this morning from Florida, I believe, with that. So that's one of the first, what I think they said was missions that's going the farthest away from Earth that we've been in a vast number of years. And
quite a long time.
Yeah. For this mission for the Polaris Dawn using the Falcon 9 rocket for SpaceX is going to be going out 450, I believe, miles away from Earth. And just for reference for our listeners, if you're listening to this, it's 255 miles for International Space Station, which we covered how the replacement of batteries has gone on that. Mm-hmm. The Hubble, I think, is 325, and so this is 450. So it's pretty far away from Earth. And the thing that we wanted to check out is a couple things on that. My curiosity, I said, Jeff, this morning, I was like, hey, what type of batteries do they use? And you might think it's Tesla ones. Interesting enough, on the Falcon 9 rocket, for some of their systems, they use our one of our faves. It's lithium-ion batteries in their 18650s, which is kind of cool. Also, I was wondering, the interesting thing I would say about Polaris Dawn is their space suits or their EVA suits, because these suits are essentially new. We were checking them out. They have a heads-up display and camera in there, so I was basically saying to myself, they got to have batteries in the suits as well. And there's all this talk about what type of batteries do you use in space, because obviously compression, there's less gravitational forces, clearly, in space.
We talked about how it was colder.
Yeah, as well. And so the batteries in these suits, and we weren't able to find exactly battery chemistry or battery type, so we'll do a little bit more research on these, but we were able to find what they're doing. So obviously powering that heads-up display. They also work on the ability for compression in the suit. So it's almost similar to if you were going down in the ocean and you needed to be able to pressurize. Well, it's pressurization and depressurization, so you don't essentially get what they call space bends, as well as the ability to heat and cool it, because you're clearly going to have different temperatures that are going there, and dehumidification, because if you think about it, you're breathing inside that. So you need to, there's some humidity that's coming out to be able to make sure the systems are there. This is pretty neat. WMUR, who is New Hampshire's one where I am located, covered a lot of this because Scott Poteet is actually locally from New Hampshire, and he's the mission pilot that was there. I saw him this morning giving the thumbs up, which is a good thing as you're the pilot there. What I did notice too, it's clearly most of this is being done by the computer, because it's not like he was doing things when you look at the old space shuttle where they're kind of using their hands to, what I'd say, quote unquote, drive. He did have some type of apparatus on his left thigh that I think he was utilizing to be able to look at the display. But they said since there's a heads up display in these visors, that's what they're utilizing to see all the statistics on the rocket and to be able to see what's going on.
Very cool. The other thing about the suit before we move on is that they use it for both when they're inside and outside. So this is, often you would see like astronauts sort of, donning their, spacewalking suit, and they'd have to, get into it and all that stuff. This is basically one suit fits all, so to speak. Yeah,
which is I think awesome. And if you think about it, it's more efficient, right? You're having the same suit for most of these type of things. So you're not having to worry about, does it fit? Is there certain variables? Is X, Y, or Z locked? Or all these pieces? And so it's a crew of 4. So we wish them luck. Obviously, there's inherent risks of going to space, but it's very interesting too in terms of what they're trying to do. For me, obviously in medicine, there's a lot of health related pieces that they're looking to do for long duration space flights. Quantify venous gas emboli that are monitoring that via ultrasound. They're gathering data on radiation environment to better understand space radiation's effects on human biological systems. And they're providing biological samples towards multi-omics analysis for long-term biobank, which I guess is a bank that they utilize when I looked that up earlier to be able to look at all of the data on human bodies that occurs in space, as well as the research related to spaceflight-associated neuroocular syndrome, which is a key risk to human health in long-duration spaceflight. So I don't know if something happened. I mean, I know a fair about ocular reflexes and whatnot that goes on, but this is a pretty neat thing. So obviously this flight will be the first of many to try and get, I would say, farther away from the Earth. And obviously within that, batteries are going to be a huge component, right? Once you get into space, essentially you're going to need to utilize that. So as time goes on, I'd be super interested to figure out, so what are the solar panels on this? How are they charging this? How many batteries are in there? What type of batteries? How many kilowatt hours total are they having in this system? Voltage requirements. I mean, my guess is most of these are DC-based systems. One would think so, possibly.
Yeah,
but I don't know. So all super
and
awesome
much redundancy. I assume
tons of redundancy. Yeah.
And do you know this? Like how much degradation there might be of the amount of solar energy you could capture in space versus the amount you can capture on the surface of the Earth? Do you know, like, there's got to be some difference, right?
Well, you would think, obviously, the ozone layer is somewhat, quote unquote, protecting us, right? So there's a radiation protection that's occurring, which is why they're looking at all these effects of the solar radiation on the body. Yeah, so I don't know. Are you getting more efficiency or able to capture more?
Is it a different kind of panel? Like, I mean, this is stuff we'll look into and report back.
Oh, completely. And I have a fairly good guess that they don't have to worry about clouds.
No, wouldn't think so.
No. Yeah,
black holes maybe.
Right. Good point with that. Good point with that. But obviously, EV needs and battery needs in space. But there's some people have some battery needs that are here on Earth. And Jeff, did you have some potential battery needs that you were going to be looking and you might have looked at with a company that we had on the show?
Yeah, we could certainly get into that next. Excuse me. So we, many years ago now,
I know.
Actually, we had David Whitlock from Lion Energy on for 2 episodes. It was episode 49, which was December 18th of 2020, the end of our first year of podcasting at I Like Batteries. And then the show 51, because remember we did our 50th anniversary or 50th show show in between. But on January 1st, 2021, we also did the second half of the Lion Energy chat on episode 51. David Whitlock has since departed Lion Energy, but they have their Sanctuary line, which is combination inverters and batteries that you can use for home backup. So they have a little website on their website. They have a little form you fill out and basically say, hey, I'd like a consultation. So I signed up and did this last week and explained who I was. So I spoke to another David, Dave Smith, who is the director of sales at Lion Energy currently. And we spent about 45 minutes on the phone, but I assured him that I knew a thing or two about batteries and we could skip a lot of the sales pitch part of what the Sanctuary gives. And the main thing that they do, and this was the most attractive thing to me, and I think we've mentioned this on the show before, when you do normal solar installations on your house, they are grid-tied solar, which means that if the grid power goes out, your solar panels are useless. So it basically has a safety procedure so that basically you're not putting a voltage out onto the onto the grid, so that people are working on the grid to restore it or keep them safe, which is a good thing. We love safety here at I Like Batteries. But the Sanctuary is a different sort of setup. So it allows your solar panels to continue to be used, as well as getting input from the grid and a backup generator. So this was part of the backstory. Is we bought this new house in January. It had a propane-fired furnace and many propane appliances. We didn't want to use those fossil fuels anymore, so we removed all of that. But it also had a 8-kilowatt generator outside, supplied by this propane tank that's buried in the yard. That 8-kilowatt backup generator was fine for the old power demands for the house, but since I put in 2 ducted and a single mini split heat pump system, the power requirements have gone up especially for heating in the winter. So we have a quote, and I'll give you the rough numbers too. So we have a quote for a 26 kilowatt generator plus the whole house transfer switch, and that's about $16,000. Just as a point of reference, basically. Okay. There's no. I thought there might be some utility because the existing generator is there, but they can't because they need a thicker cable that goes from the generator to the panel. So you can't even reuse the wiring that's buried in the driveway. So that's all in single cost. Also propane a bit able because we have the tank buried in the ground. All's well with that. So part of my thinking about talking to Dave Smith at Lion Energy about their Sanctuary is, could I just keep the current generator? Like, could the generator be the thing that inputs and charges the batteries during a power outage? So we didn't get into all of the specifics of how much I would need from a battery backup standpoint to power my house and for how long it would run it. So I'm gonna follow up with him briefly, but I do think it's going to end up being somewhat cost prohibitive.
Oh, okay.
The summary is, again, they sell batteries and inverters. They have a 33 amp limit per inverter.
Okay.
You can string 3 of these together. All right, so you get basically 100 amps.
Okay.
With one set. And then you can attach I think 3 batteries to each one, but maybe I have to double check on that. But they have he talked about he called it 2 and 4. So 2 inverters and 4 batteries. Gives each battery's 13.5 kilowatt hours. So that gives you the 2 inverters and 4 batteries gives you roughly 60 kilowatt hours fed through 66 amps into your house. The rough cost of a single inverter and a single battery installed, according to him, is roughly $20,500.
Okay, so that's a bit.
That's a bit, and then you can think of it as roughly $5,000 to $6,000 per additional component that you add to that system. So you want to add another inverter, add $5,000. You want to add another battery, add another $5,000. So if you talk about the 2 and 4 setup, that's 3 additional batteries, right? So another $15,000, and then maybe another $5,000 for a second inverter, right? So now we're at $40,000.
Whew.
Right. And I have it down here. Yeah. So he talked about sort of a single battery setup, just thinking like a single 13.5 kilowatt hour battery. You get 5 to 8 hours at a 15 amp draw off that one battery.
Okay.
There are many more amps required for the heat pump system. So all of that sort of was just like starting to feel like it wouldn't be enough. Like maybe it could work, but I don't think it would run the house for very long. And that's sort of the question I'd like to answer. Like, what's the, like, realistically, I'm going to send him pictures of my setup and draw some, give him the full details and see what he comes back with. But it's sounding not great.
Yeah.
Because I don't even have the solar panels yet.
Right.
But it's so attractive because of the fact that you would effectively be, you could be set up for off grid, and that the only thing the grid is doing is topping off the batteries. So if the grid's not available, you could use the existing generator to top off the batteries when the solar isn't working and the power. You know what I mean? So that was the part of the attractiveness, and Lion Energy is one of the only, if not the only, company doing this.
Right.
So it's like just the whole, like, it's so attractive, but I just think I can't do it right now.
Yeah.
Is ultimately what the conclusion is. But like the possibility is there. It's like, oh my gosh, just thinking about putting 12 or 13 kilowatts of solar into the system, and like basically it would allow that to pass through, right? So it would basically, like, you can set it up so that when the sun is shining, it's like, hey, let's power the house, and if there's any extra power being generated, let's top off the batteries.
Completely
is basically the setup. And then obviously at night you're using the battery power, but you can set it up so that, it only uses so much of the battery power, and then it charges from the grid, or so I think, long term, I'd have to know how many batteries I would need. Like, I might need multiples of these systems, and then it starts to get like, okay, now we're going to spend $100,000 on a battery system. Like, that just doesn't seem practical at this point. Anyway, questions. What do you have?
It's a lot of money, right? And we've talked about this even from a standpoint of battery costs coming down, but it's still a lot of money when you look at something larger like a house, and because you're heat pumped. Although, can I give a little update on my heat pump? Because I have a heat pump. Right?
Yes, you do.
Which you were excited about. In fact, I think maybe we talked about this on the show. So the Wave 2 came, and I don't know. So, and folks, what we're talking about is in the battery shed where I'm doing more and more work. I'm in the studio in the basement right now, which is completely off grid, which is great. But the shed is completely off grid and powered by batteries and powered by solar. So one of the dilemmas is making sure cooling and heating. Right, and so I had tried some portable air conditioners and things like that, but they're energy hogs, right? There's not a lot of them that are, and they all are more BTUs than I need because the shed's smaller. So the Wave 2, and when I say the Wave 2, it's talking about the EcoFlow Wave 2 came. I built a nice little, I kind of measured everything up. I built a nice little rack to hold it so it's right towards the window to be able to use. And then I have my EcoFlow Delta Max that's there, as well as the River 2 Pro. and all these lined up. So it's great. So I was able to use it to do some air conditioning and run them effectively. It was awesome. And one of the things that the Wave 2 you can get, I did not get with this, is a battery that essentially attaches onto it, and then you can be able to run it off that battery. For me, since I have other power stations from EcoFlow, I've been doing that. And I did notice on Amazon that they had a discount on the Delta 2s because they're launching a Delta 3, and they being EcoFlow is doing that. So talk about difference in prices. I know this is way smaller, but we're just saying orders of magnitude in terms of something. Right now, Amazon's got a Delta 2 with 1,024 watt hours and two 100-watt solar panels, and they're rigid. They're not the flexible or portable ones.
Yeah, not folding. Yep.
For $649. So if we look at that, we're really almost at 50 cents per watt hour, so to speak. And then your panels are under $1 per watt, if I would say, if we're kind of putting that all together. So obviously way smaller scale. It would be interesting if we did the same math to scale it up.
Right.
But obviously BTUs that I'm using, I think we did quote this out when we did the review on the Wave 2. I think I get about 5,500 BTUs for cooling and 6,500 BTUs of heating to be able to do that. So I think it's all about size. It's all about the batteries used. But clearly there's applications of being able to do this for different things. But it comes down to solar panels. So how are you going to charge it? Obviously, I've been pretty happy about my exercise charging as well. So I've been in the basement biking, Jeff. So
nice.
Yeah.
Starting to cool down too out there. So
it is. So it's nice. It's nice to get energy. In fact, I feel like we want to have Jim Gregory on again, talk about him. I'd love to see how his system's progressing at Pedal PC for that. But being able to charge it in different ways. I found something super interesting, though, in an article, and we covered this type of application, but it says Switzerland covers the Alps with solar panels now that they've achieved something impossible. But, Jeff, did you see this article? Because it's almost like they're tricking you into it. It's a little clickbait with the fact that they're covering the Alps with solar panels, but they didn't really cover the Alps.
They're not covering the Alps. They're floating solar panels.
They're floating solar panels in the Alps on water. And we did cover a lot of these solar panels that are out in the water to be able to get some energy. But my joke with this to our listeners, we're going to try and do our best to describe this. Essentially, there are solar panels that are in the Alps which is a very beautiful water because it's very clean water of melting. But it looks like a giant silicone chip that's sitting in the water that basically is the way it looks. So if you look at a microchip in a computer, it looks like that. It's a significant amount of energy that they have up there floating in the Alps.
Yeah, they have this system would have a total capacity of 448 kilowatts.
Yeah.
Which is a heck of a lot. The other thing they mention here is and this has been going on for a while in other reservoirs and water-based solar installations. I try not to say solar systems because it just gets confused because we were talking about SpaceX stuff.
This is a floating solar farm is how they define it. Just to be, which seems completely right. Yeah,
but they also they help prevent evaporation.
Yeah,
right. Because they're So anyway, I thought that was another interesting tidbit to share with our listeners.
And so here's the piece to think about this, folks, too, is that we don't think about when you're going up the Alps, you're doing these things. Getting power up there is rather difficult. That's a pretty long line to run. So applications, and you think about applications in space of batteries, but you look at applications at altitude to be able to say, hey, we've got all these solar panels at 448 kilowatts to power some batteries and to supply all these things out there that realistically at higher altitudes, the ability to get really strong and higher efficiency solar is great. So I think I like the innovations that are happening. Obviously, I like batteries in terms of this podcast, in terms of things. So I thought this was an interesting factor that I had never seen what they would say is a reservoir that's a little bit high above sea level.
Yeah.
Just a tad above sea level. But something that might happen at sea level, and you were excited about this, and we missed this in pre-show, how excited you were about this. But you want to tell our listeners about the 52 billion solar panels that are potentially going to be installed in the project, and that's, you're like, what, 52 billion solar panels?
Yeah, it sounds like a made up number, but it's not. This is a project that actually has been kicked off, and my comment was, so there's basically the idea is that roads should be covered with solar panels, right? We've got all these roads that are just, out there, miles and miles and miles of them. So there's this huge project, again, as Mike said, to get 52 billion solar panels installed. And this, multiple times the energy needs of the United States, right?
Oh, yeah.
Sort of what they're talking about. Offsetting almost 30% of carbon emissions would be fantastic. But they're basically saying 3.2 million kilometers of highways throughout the world, not just the U.S., would be the goal. There's obviously challenges. With respect to, the idea is that, they'd be elevated over the road surface. So you've got all of this infrastructure that needs to be put in place to carry them. There are maintenance questions, training on how to do all of this. But Mike and I were just musing about how obvious this is and why it hasn't been done more before, but also thinking about how it's possibly a way to add some resilience to the grid, rest stops and, battery stations, for EV charging, et cetera. I mean, this has, to me, is like a no-brainer. Like, where do I sign up to help make this happen?
Right. And I think where we're seeing this now, because we're not, I don't know of any areas where this is over the highways to be able to have, is I've seen this in a bunch of airports and parking lots, and you see more and more depending where you travel. I mean, I think when we were over in Italy, I saw this a fair amount in that, you get long-term parking, so to speak, and they've got all these solar panels that are essentially shading the cars so that the car isn't getting super hot while you're parked for a long period of time, yet you're collecting energy. I mean, I think the more we continuously look at innovations and how we can do this better, really, it comes down to any parking lot. Obviously you work from home, but I'm going into work and I park in a parking lot all day. There's no reason why you shouldn't be able to have this and be able to utilize it and say, hey, like, this is kind of cool. I could be able to do this. And even, what it makes me think of is we had your interview on episode, I believe it's 107 and 108, if our listeners want to go back, of with Sunbolt, when we talked to Ian Jones.
Oh, yeah.
One of those, and Sunbolt has a company, if you're not familiar with it, to our listeners, is that they actually have like little picnic tables and different things out in the community where there's a solar panel above it. So like, hey, if it sprinkles a little bit, you have this. Great installations for campuses and different things where you can charge your phone, you can charge your laptop, charge all these things. And so just great innovations that you see around, just saying, hey, let's just take this space that we're already using, let's put something there, let's have it, and let's let somebody utilize it in a great way and try and be better for the planet. And I think obviously it's not one of our missions of here. It's I Like Batteries to help educate you, and every week or every other week whenever we have a show and say, hey, learn something. So maybe you learned something about EV suits and going up there. Maybe you learned about floating solar farms, and maybe you learned that maybe you can power your house or not power your house off of batteries. But hopefully you have a great week. Stay fully charged, or like we said, with your batteries, at least 80%.
Thanks for joining us.